Hello everyone, welcome to the next lecture in the topic spectral reflectance properties of water body. In the last class we started discussing about the properties or the spectral properties of water, how water will transmit energy, how water will absorb energy and all. So, today we will continue with that particular topic. So, in the last class we analyzed little bit in detail about how vegetation will influence the spectral reflectance property of water. Today we are going to start with analyzing how suspended sediments will influence the spectral reflectance property of water bodies. So, what exactly suspended sediments? Suspended sediments are? Suspended sediments are anything that is not dissolved but present within water body. Say you take a cup of water, put some sand in it and mix it vigorously. So, before settling down to the bottom, the sand will be floating inside the water, right. It will not dissolve and it will be floating. So, such things are called suspended sediments. So, after a flood, like it will carry lot of soil particles, it will be depositing it in the nearby water body. That will be like lingering in the water body in suspended fashion for some time, or anything else, maybe like some living organisms, whatever. So, whatever is present in the water body without getting dissolved, we call it as suspended water bodies. So, as the concentration of suspended particles increases, the reflectance will change. We know that for soil, we studied, the reflectance of soil is actually like a linearly increasing curve. The reflectance increased with increasing in wavelength, that we have already seen. Same effect will come even in water body, because most of the suspended particles are soil particles. So, when soil particles or the concentration of such soil particles increases, the reflectance will increase in almost all the wavelengths, that is given in this particular slide. Here you can see this is for clean water body, clear water body, the bottommost curve. As the concentration of suspended particles increases, the reflection or the reflectance in all wavelength will basically increase. Even in NIR we will get some high reflectance because of the presence of such soil particles. And one more feature what we can observe is, as the concentration increases, the wavelength at which peak reflectance occurs actually shift towards longer wavelengths. That is, as concentration increases, the wavelength at which peak reflectance occurs shift towards longer wavelength. This is one important property. And also another important thing that we should remember is, rather than the mass of suspended sediments per unit mass of water or unit volume of suspended sediment per unit volume of water, what is most important is the total number of suspended particles. So, it is not the mass. Some particles may be dense, like some suspended sediment may be really dense. So, the number of particles may be quite low, whereas for some other thing the number of particles in a given mass of suspended sediment may be very high. Say for example, clay and sand. Clay is extremely fine in nature. So, for a same weight, clay will have large number of particles in comparison to sand. So, what happens is the concentration here, the number of particles increases the reflectance rather than the weight. So, higher the number of particles present in the water, higher will be the reflectance rather than the weight. Okay. So, this important thing we should remember, but in general any presence of suspended matter in water body will increase the reflectance in almost all the wavelengths. So, here again in this particular slide one more example is given, how the reflectance changes with increasing concentration. You can see like the wavelength of peak reflectance shift towards longer wavelength with increasing concentration. Then the next feature we are going to see is effect of depth of water column. I already told you that water, if it is fairly shallow, then some portion of EMR can interact with what is present on the bottom surface and it can come out of water body, and that signal we may see. So, let us assume say the water depth is something around say less than like 2 to 3 meters, very shallow water body. then what will happen? Blue and green wavelength can penetrate through, and let us assume there is like a thick vegetation in the surface of water, maybe some algae or something is present on the bottom surface. So, what will happen? If green is capable enough of penetrating through it, and when it will be now reflected by whatever is present there on the bottom. If it is like vegetation, then green will be reflected back, or if it is like something, some coating has been given in water body, like in swimming pools they have put some colored tiles, that may come up. So, all these things will basically come up. So, an example is given in this particular slide. So, here the effect of water depth on a stream channel is given. Okay. So, the stream channel basically contains, or the bottom surface contained some sort of like algae under different depths. If the depth is fairly shallow, then the reflectance from algae primarily came up. So, here you can see the vegetation in NIR portion and all, you can see very high reflectance. Similarly, you can see like a strong absorptance in blue region and so on. So, essentially what happens is, as the depth becomes shallow, so the features present in the bottom of the surface will influence the reflectance. But if the depth is very high, which is like if the depth is much more than the penetration depth of EMR, like I told you, blue can penetrate very deep in the order of tens of meters sometimes. Red can penetrate slightly shallow, green will have penetration something around say 5 meters. So, if the penetration or if the depth of water body is more than the penetration depth of EMR, then we will not get any signal from the bottom surface. Everything will be absorbed as EMR penetrates through. But if the depth is say only like 2 to 3 meters, then all wavelengths will get some signal about the bottom, and whatever is being present in the bottom will give its own signal. Actually, in the example I showed you about the reef example is what is actually there. In this particular slide, you can see in green band what happens, like reef means it may contain some sort of like living things or vegetation or something. This is like sand or whatever soil is present. Okay. So, in green wavelength we know like vegetation absorbs more in comparison with soil. Like if you compare the reflectance of soil and reflectance of vegetation in green band, soil will have higher reflectance than vegetation, because vegetation is a good absorber of visible portion, that we already know. So, that is why here in green band we are getting slightly lower reflectance here in comparison to this. High reflectance indicates there may be like sand particles there, whereas here there can be living vegetation there. Similarly, in red if you see, vegetation absorbs very high amount of red energy, that also we know. That is why there is not much of signal here, only we are getting signal from the soil portion. So, vegetation absorbs lot of green. So, here in these portions, like wherever I am marking now, the depth of water column is actually less than the penetration depth of EMR in that particular wavelength, and hence whatever is present there gives their characteristic signal, and that will be seen in the remotely sensed images. The next important concept we are going to see is the nature of radiance coming out from water bodies and the importance of atmospherically correcting it. Okay. So, we have seen now that water is primarily a very poor reflector. So, it transmits lot of energy and it absorbs good fraction of energy. So, if you want to sense oceans, then being a poor reflector, not much of radiance will be coming out of such oceans. If the ocean is extremely clean, no other like surface feature or surface roughness is present, then what will happen basically is most of the EMR will be penetrating into it and they will be lost and they will be absorbed after a certain time period. So, the radiance of the reflected energy coming out of water body will be fairly low. If you compare this scenario with land surface, in most of the bands, like especially in the visible and NIR bands, land surface has relatively higher reflectance than water bodies, especially oceans. So, if you want to send a sensor to space to sense oceans or deep water bodies, then essentially they should be trained or they should be manufactured in such a manner they work in lower level of radiances. That is, they should be calibrated such that they see all the lower values of radiances. But if you want to study land surfaces, then they should be calibrated to sense higher values of radiances. That is extremely important. The radiance coming out of ocean water is fairly low. On the other hand, to complicate matters more, atmosphere adds a very high amount of path radiance to it. An example is given in this particular slide. See here, if you see this, the LT, the line marked as LT represents the total radiance reaching the sensor. Here people have used some sort of modeling to understand what will be the path radiance LP and what is the actual radiance that came out of water body. So, if you split this, we will understand that the actual radiance from the water is much lower and most fraction of the LT that reach the sensor is actually path radiance. So, what this tells us? This tells us that if we want to study about water, especially deep oceans, we should do a good amount of atmospheric correction, because the signal from ocean is very low. Atmosphere adds a very large fraction of energy towards the radiance reaching the sensor. So, it is mandatory for us to do proper atmospheric correction if we want to study about deep ocean water bodies. So, now before we end this particular topic, we will see quickly two examples about how the reflectance of water changes with different substances. The first example is we will see about the presence of suspended sediments. So, in this particular slide, a natural color image is being given there, where this is like suspended soil particles. So, as the soil particles, like this is being washed from a river, this is a river delta, we can see like as the suspended sediments kind of spreads away, you can see the reflectance is drastically changed. We are having increased reflectance, it is appearing brown in color because of color of sand. On the other hand, if you look here and all, where deep sea is there, we are seeing it purely blue because nothing, no contaminant is present there. So, we are observing it as blue. I already told you the reason for this. Blue will be scattered a lot. So, essentially the presence of suspended sediments will change the color of water bodies. Similarly, presence of phytoplanktons. As I told you, any presence of vegetation in the water will change its color. It may give like a green signal, it is appearing green in color because of mainly presence of phytoplanktons present in ocean bodies, whereas clear ocean water bodies appear blue. Portions of water where large amount of phytoplankton is present appears green in color. So, as a summary for this particular lecture, we have studied in detail about the spectral reflectance properties of water and how different factors influences this. With this, we end the topic of spectral reflectance property of water. Thank you very much.